Okay, so now we know that our original problem with four constraints can actually be reduced to these unconstrained problems. And this is through our observations and analysis about that problem. We know some properties about that problem, and then we may reduce that problem to a simplified form. But the optimal solution is, of course, still there. Okay, so to solve this problem, recall that our decision variables are the quantities that we offer to the agent or to the consumer. Okay, we're going to decide how much we want to give to the consumer of high type and how much we want to give to the low type. We will collect some money from them, and that can be decided by the two binding constraints in the previous slides. Okay, so now we have this question with Q as our decision variables. The good news here is that because V is strictly concave, we can show that this two variable problem can also be shown to be strictly concave in QH and QL. Okay, in particular, QH and QL are somewhat unrelated. Okay, unrelated. So all you need to do is to differentiate this objective function with respect to QH and QL. You're going to get two equations, and that's going to help you to derive the first order condition like this. Okay, as long as the parameter is not very weird, then your second best solution, your second best menu can be derived or can be expressed in this way. So for QH, this of course comes from your derivative with respect to QH. When you do that derivative, you may see that only this part matters. Okay, only this part contains QH. So your QH comes from there. It shouldn't be too hard. And for QL, you get something from here and here. So you probably want to do this exercise by yourself. Differentiate the blue parts with respect to QL to see whether you can get something like this. This condition is for you to have a positive denominator here. If your denominator is negative, then that means your quantity should be negative, which is impossible. Okay, so we have a condition here. If this condition is violated like this, then your QL will be modified to the minimum level, which is 0. That means you find the low type consumer too unprofitable, so you will not really trade with him. Okay, and in any case, you will trade with the high type guy like this. Okay, so that's our solution. So now we have our last step is to verify the previously relaxed constraint ICL is satisfied. To see this, note that as an optimal solution we have these two equalities, right? So ICL, this guy, can be replaced by these two equalities, and after some arithmetics we can show that it will be something like this. And then this is positive, this is positive, this is negative, so ICL can be satisfied with any optimal solution. So with that, we complete our analysis about this problem. We can really show that how to get an optimal or second best menu according to our parameters. Okay, that's the end of the solution. Now we want to talk about some findings with the solutions. The first thing is to compare our second best solution with the first best solution. And here we use tilt to denote the first best solution. Okay, when we compare the consumption level or the quantity with the first best quantities, immediately we can see that for the high type consumer, the two conditions are the same. So the high type consumer will still get the first best amount. So that means at the high type part, this solution is the same. Okay, but for the low type part, we can show that this is the condition with complete information, and this is the condition with information symmetry. Because this particular term is less than 1, this particular thing is greater than C, okay? And then that means you have this relationship. Your V prime Q tilde L should be less than your V prime Q star L. And because V is increasing and concave, that means V prime is decreasing. Okay, the slope of this function is decreasing. And what does that mean? Let's look at this figure. Suppose you have a decreasing function, and you know your, let's say call it f. If your f of a is less than f of b, then that means a is greater than b. Okay, so if v prime q tilde l is less than v prime q star l, then that means q tilde l is greater than q star l. Okay, just like this. So the high type consumer will still get the first best amount, but the low type consumer will only get something that is less than the first best amount. Okay, so that means our second best solution and the first best solution are different. Okay, so the first thing is to see is different, and different doesn't definitely means inefficiency, because complete information is the best outcome, the best possible outcome. And with information symmetry, our outcome is different. In particular, the consumption level is lower. Okay, so the whole system is creating fewer utility to everybody. The system is inefficient, and that of course is because the seller does not observe the consumer's type. Okay, this inefficiency comes from information asymmetry. Then you will have one question. There is a deviation from the first best solution. The second and the low type consumption level is smaller. Is it possible to become bigger? According to our analysis, it's impossible. You will only decrease the consumption level for the low type consumer. You will never make it larger. And also you will not try to alter your high type consumer's consumption. Why? Let's answer it. So regarding the consumption level, the most important observation is that we decrease QL. Why the seller want to decrease QL? Remind yourself that the seller is trying to maximize its own profit. So the seller do so. If the seller does so, it must be because it is beneficial. So think about this. Suppose the seller offers the first best menu, then the high type consumer will pretend to be a low type, and the positive payment that the high type consumer can get is derived like this, right? So this tells us that if we want to extract surplus from the high type consumer, I should decrease QL. As long as I cut down QL, I am going to limit his incentive about lying. Okay, when I decrease QL, the high type consumer will find it less profitable to pretend to be a low type. So that's the main reason to decrease QL. Even though it creates some inefficiency, even though it disallows us to earn as much as in the past from the low type, that's going to help us get profit from the high type. Okay, so the main reason to decrease the low type consumption level is because of this. because I want to cut down the rent obtained by the high type consumer. Then we have some other observations. In equilibrium, the low type consumer earns nothing, okay, because IRL is binding. However, we have shown to you that the high type consumer still earns a positive amount. This and this looks very similar, right? But because Q star L is less than Q tilde L, we have successfully lowered the high type consumer's rent, or in this case we call it information rent. The high type consumer can earn a positive utility because of what? It's not because he is more diligent, or it's not because he has more power, or it's not because he is smarter. It's simply because it has some information. Okay? When he does not have that piece of private information, no matter it's low type or high type, it gets nothing. But now, because the agent has a private information, the agent can enjoy a positive utility in expectation, and that is called information rent. Okay, so we have two observations now. At the low type, the quantity becomes smaller, and the low type consumer gets nothing, but the high type consumer can still get something. Okay, finally, note that the high type consumer's rent depends on Q star L. Okay, so all we want to do is to cut down the information rent obtained by consumers. You are the principal, he is the agent. The best way for you to optimize your profit is to try to limit the agent's profit. If you want to do that, you will try to cut down his information rent, because that private information gives the agent some rent, and you want to limit the amount of rent, then you will be able to maximize your profit. Okay, so now we have introduced the idea of information asymmetry, and how may we formally formulate it as a mathematical problem. We are able to solve the complete information problem, and we are able to solve the second best, or the information asymmetry problem. We have the first best and the second best mechanisms, and we see that we have the following observations or insights. For the second best solution, basically we have three things. First is monotonicity. The high type consumer will be offered more than the low type, and this is because the high type consumers prefers a higher consumption, because they prefer that, so you give them that. That's going to make you easier to earn more money from them. Okay, monotonicity. And then is something we call efficiency at top. The high type consumption level is efficient, and that basically means Q star H is equal to Q tilde H. Now, this is the so-called efficiency at top. The high type consumption level is efficient. Finally, there is no rent at bottom. The low type consumer earns no rent, while the high type consumer can still earn some rent. Okay? Finally, don't forget that there is a downward distortion from the low type. So, for the low type, the second best consumption level is less than the first best consumption level. This is a downward distortion from the original efficient level to a smaller level. Okay, so information asymmetry creates these situations, creates the downward distortion. But keep one thing in mind: information asymmetry helps the agent, or protects the agent. If there is no information asymmetry, then the agent is going to earn nothing. Okay, so the information asymmetry is going to earn nothing. with information asymmetry, the agent earns something, so the agent is happy because he has that piece of information and he will try to always hide that piece of information for the agent to earn something. So sometimes this is good, but sometimes it is bad from the society's perspective. For example, if the principal is an employer and the agent are some employees, we hope that the employees can still get some positive utilities in general, right? So in that case, we prefer to have this information asymmetry. But if we consumers are principal and sellers are agent, then, for example, if product quality or the raw material source are their private information, then it's bad to the society. So whether information asymmetry is really good or not really depends on what's the problem we are talking about. But if we are talking about efficiency, then generally it's bad. If we are talking about the principle never prefers the agent to have some private information. Okay, so that's our first introduction about private information. We will give you more examples and using different perspectives to talk about this problem and how information and information asymmetry may affect the interactions of all players in a decentralized system. That's the end of today's videos. Thank you.